Okay, so my objective is the student is able to analyze situations using involving interactions among several objects by using free body diagrams that include the application of Newton's third law to identify forces. The example problem is taken from Barron's AP Physics 1 and 2 test prep book. So here's the problem. A 3 kilogram block is placed on top of a 7 kg block. It's shown below. The coefficient of kinetic friction between the 7 and the surface is 0.35, and a horizontal force is acting on the 7 kg block. So, part A, draw a free body diagram for each block. Here is 3 kg, and here is 7 kg. Okay, so first let's do the 3 kg block. Vertical components, first of all, there is force of gravity pushing down onto the 7 kg block, and according to Newton's third law, the 7 kg block is applying an equal but opposite force onto 3 kg block, which is the normal force. Okay, so let's move on to this. Obviously, force of gravity, this time a bit bigger than the 3 kg block, pushing onto the ground. But you also have to remember that since they are stacked on top of each other, the 3 kg block is also pushing down on the 7 kg block, which in turn pushes down on the ground, which adds the two forces of gravity together. And Newton's third law, there is a reactionary force, a big force of normal force 7, which is equal to these two combined. As given by the problem, there is also horizontal force F, and also given by the problem, there is a coefficient of kinetic friction between the 7 kg block and the surface, which indicates that there is kinetic friction. But we're not done yet, because nowhere in this problem does it say that both of these blocks are frictionless, meaning that there's still friction in between these two. And since the 7 kg block moving to the right, the 3 kg block will want to naturally move to the left relative to the 7 kg block because of inertia. But since they are both moving together as a system, it's because of the static friction that is keeping it from sliding off. So instead of going this way, the coefficient of static friction pushes it to the right. And because of Newton's third law, there is an equal reactionary force, points in the opposite direction, but equal in magnitude. And that's it for A. For B, calculate the magnitude of the applied force F necessary to maintain an acceleration of 5 meters per second. So this one is just Newton's second law, F equals ma. In the y direction, the forces add up to 0 because it is accelerating horizontally. So this is equal to this plus this is equal to this, etc. And in the x direction, it is equal to F minus kinetic friction, because it is the opposite direction. The friction is opposing the applied force. We're not counting force of friction because they're acting in between. It doesn't contribute to the motion. Also, they cancel out. Total mass of the system is equal to just these two masses added together, equal to 10 kg. Mass of the system because, of course, the entire system is moving, is accelerating at 5 meters per second. That's given. Okay, so all you have left is this as an unknown. And while we're not given this, we are given the coefficient of kinetic friction. You know that f of k is equal to mu k times f of n. We're given that this is 0.35, and because of this, we know that Fn of 7 is equal to these two combined. And this is Fn of 7. So that is this plus this. force of gravity of 3 plus force of gravity of 7, which is mg3, which is 3 times 10, mass times gravity, plus 7 times 10, mass times gravity, which is equal to 100. Multiply them, and you get kinetic friction is equal to 35. Let me rewrite the equation. Is equal to m total A, isolate F, because that's what we're solving for. Oh, sorry. Plus Fk, which is equal to total mass, 10, times acceleration, 5, plus 35, is equal to 85 newtons. And that's part B done. Part C, find the minimum coefficient of static friction necessary to prevent the 3 kg block from slipping. Alright, so let's take a look at the free body diagram. There's only static friction that's affecting the 3 kg block's motion. So if we do F equals ma again, the total force is this, because of course these two equal 0, is equal to m, the mass of 3 kg, times the acceleration. And since this system is accelerating at 5 meters per second, so is the 3 kg block, because it's moving with the system. So we're calculating the coefficient. So this is mu s times f of n 3. So we know this, it's just mg. We know this, and we know this. So we're good to go. Equal to m3a over f of n 3, which is equal to mass of 3, which is 3 kg, times acceleration, 5, over mg, which is the mass times gravity, which is equal to 1/2. And we're done. Cool.